Good afternoon, all the participants. We will start our webinar at sharp 3 p.m. So please stay with us.
I have muted. Huh? No, see.
Good afternoon, all. Good afternoon, all. So we are going to start our webinar. Myself, Dr. Arpita Pandey Tiwari, Assistant Professor, Department of Stem Cell and Regenerative Medicine and Medical Biotechnology, is extremely pleased to welcome all the dignitaries and participants who have joined to attend the webinar on current trends in biosciences. I welcome you all on behalf of DYP Patil Education Society, Medical College and Research Center. The motive of organizing this webinar by Stem Cell and Regenerative Medicine Department and Medical Biotechnology Department is to make students aware about the opportunities and the immense potential of emerging areas in biological sciences. I hope I'm audible. The future belongs to those who have great vision. It was the futuristic vision of Honorable Dada, Padam Shri Dr. D.Y. Patil, that the D.Y. Patil Group is now a leading brand known for imparting quality education in frontier areas of science. We are amongst the very few universities where the science students are encouraged to work with medical students and doctors, creating an interdisciplinary approach of modern education. The fruits of Center for Interdisciplinary Research have already started coming up. Recently, our Dean of Center for Interdisciplinary Research, respected Professor C.D. Lokhande, an eminent scientist, is quoted by a study made at University of Stanford amongst the top 2% scientists of the world in the field of applied physics, which is an honor to our institution. Also, our ex-Vice Chancellor, respected Professor S.H. Pawar, sir, is quoted in the same list made by University of Stanford. Further, Dr. Nana Sahib Thorat, ND Thorat, an alumni of our university and also a speaker in today's webinar, is recently appointed in very prestigious University of Oxford. And I feel extremely glad to share a news that he has been selected by European Commission and selected for Innovation Radar Award, which is a very prestigious award. And I think he's the first Indian to get this award. Currently, more than 60% of our alumni and students are working abroad at esteemed positions. This is due to very talented, dedicated, hardworking, and committed faculty of our DYP group. There is a shlok, Kshan Shah Kanashaiva, Vidyamartham cha sadhyayet, Kshan Tyage Kuto Vidya, Kan Tyage Kuto Dhyanam, which means knowledge should be gained through minute by minute efforts. Money should be earned by utilizing each and every resource. If you waste time, how can you get knowledge? If you waste resources, how can you accumulate wealth? So DYP offers platform to gain knowledge and resources for not only securing future, but also making the student capable enough to bring change in society. This is possible due to foresight vision of our president, Honorable Sanjay D. Patil, and I take this opportunity to thank him for his constant support and guidance. I also wish to convey my gratitude that we are very fortunate to have extremely talented and dynamic Vice Chancellor Professor Mudgal sir, who has innovative ideas and perfect planning skills. My warm thanks to our beloved Professor Vice Chancellor Dr. Shimpa ma'am for making the most complex things easier and make it happen. My hearty thanks to Dean Professor Rakesh Sharma sir for constant support and guidance. And I'm very fortunate to have a great scientist and a very humble personality, Dean for Center Disciplinary Research, who is always there with his expert advice at every step. My heartfelt thanks to Registrar Sir, who is always there to help us in our every small and bigger issues. I convey my thanks to Professor S. Mohan Karupail, our HOD, whose knowledge and experience is constant source of inspiration to faculty and students. A big thanks to my dear colleagues and students of CIR and Stem Cell and Regenerative Medicine for their cooperation. Also, I want to thank our corporate staff for excellent designing of flyer and media promotion, and Mr. Suraj for his technical support. Now, without wasting time, I would request our HOD, respected Professor S. Mohan Karupail, to give a brief introduction of our department.
Welcome to the DY Patil Education Society at Kolhapur. Our university is a UGC recognized NAC accredited A-grade university located at Kolhapur. It was founded in 2005 by Padma Shri D.Y. Patil. Current Chancellor of the university is Sanjay D. Patil, and our Vice Chancellor is Dr. Rakesh Kumar Mudgal, Provisc Shimpa Sharma, Dean of our medical college is Dr. R.K. Sharma, and the Dean and Director of the Center for Interdisciplinary Research is Professor C.D. Lokhande, and our Registrar, Dr. V.V. Bosle. Our Department of Stem Cell and Regenerative Medicine and Medical Biotechnology is headed by me. And we have 5 faculty members: Dr. Magnon Joshi, who is a stem cell researcher; Dr. Arvind Gulbake, he works on drug delivery; Dr. Ashwini Jadhav works on signal transduction; Arpita Pandey Tiwari works on nanotechnology; and Shivaji Kashte works on tissue engineering. Our faculty has affiliation. These are the past affiliations of our faculty. Our faculty has affiliations with the Indian Institute of Science, University of Texas at Austin, Karolinska Institute, and Defense Institute, Advanced Defense Technology Institute at Pune, and so on. We offer 2 MSc programs. In fact, our university is one of the few centers of learning in stem cell and regenerative medicine and medical biotechnology. We also have 2 postgraduate diploma programs in stem cell and regenerative medicine. And this year we are introducing a diploma in bioinformatics. We have PhD programs in stem cell and regenerative medicine and medical technology. We have state-of-the-art technologies for MSc and PhD research, including RT-PCR. And our department has been actively involved in COVID laboratory in the identification of viral infections, SARS-CoV-2. And we are very actively involved in organizing international seminar program. This was a seminar we organized recently on cancer biology, basic science to translational research. The keynote address was given by Dr. Gokul Das of Roswell Park Research Center, USA. And another program we organized was on angiogenesis, targeted angiogenic therapy. Professor Marcel Bloch was from Aix-Marseille University, was our keynote speaker. And we are actively involved in organizing training program for the students. This is one of the flow cytometry workshop. And these are some of the research areas pursued in our department. We are involved in stem cell, cancer stem cells and stem cell research, and tissue engineering, and solid lipid based drug delivery systems, nanobiotechnology, Candida albicans biofilm formation, signal transduction, and drug repositioning. These are some of the areas of research we are involved in. And recently we got 3 patents. 1 patent on method of constructing tissue engineered human ear pin prosthesis, synthesis of composite artificial skin bioink for 3D bioprinting and wound killing, and process for embedding oleic acid coated super paramagnetic iron oxide nanoparticles. So we have a couple of MOUs, one with Stem Cell Cryopreservation Limited, a company involved in stem cell and cord blood cell banking, and Chonnam National University, Hong Kong University, and Yegnam University. All the 3 universities are located in Korea. But just to highlight the major highlights, work in the department is recognized by the government of Maharashtra, and 3 awards were awarded to D.Y. Patil University under the Startup India Innovation and Healthcare Program. The Startup Hero of Maharashtra was recognized as, and Mr. Abhinandan Patil got the Startup Hero Award. Innovation, Healthcare, first prize went to Dr. Deepak Sawant, and Innovation and Healthcare, second prize to Ms. Priyanka Popat Patil. Thank you. So it is my great pleasure to welcome you all to this webinar.
Thank you, sir. Now I would like to invite Dr. Shivaji Kashte, sir, to give introduction of our today's guest, Dr. N.D. Thorat.
Hello, good afternoon to everybody. It's an honor to introduce our alumni, Dr. Nanasaheb Thorat. Dr. Nanasaheb Thorat has completed his PhD from D.Y. Patil University, Kolhapur, under the guidance of our ex-Vice Chancellor, Professor Dr. S.H. Pawar. Dr. Nanasaheb Thorat is an outstanding experienced researcher currently working as a Marie Curie Fellow at the University of Oxford, Medical Science Division. Dr. Thorat demonstrated the extraordinary ability of independent thinking, leadership, time management, and communication qualities throughout his doctoral research and Marie Curie Fellowship. Dr. Thorat is a two-time winner of the world's most prestigious fellowship, that is Marie Curie Fellowship, and also working as an evaluation and panel member of the Marie Curie Fellowship's applications for life and engineering sciences since the year 2019. Dr. Thorat has published 50 plus peer-reviewed journal research papers and articles, 5 books, 10 book chapters, presented 5 keynote speeches, 15 invited lectures, and 5 oral presentations at prestigious scientific peer conferences in Singapore, France, Germany, USA, Ireland, Poland, South Korea, and India. He has received international acclaims and awards for research contribution, generated research funds in excess of 7 crores, supervised students, junior researchers, and actively participated in outreach and scientific dissemination for the service of the wider community. Dr. Nanasaheb Thorat is the first Indian awardee of the European Commission's Innovation Radar Grand Prix of the Innovation Radar Prize 2020, and many other national and international acclaims on his name. Dr. Thorat is also the winner of the prestigious fellowships, including the Japanese Society for the Promotion of Science, that is JCPS Fellowship in Japan 2017, PBC Outstanding Fellowship Israel 2016, and he has also worked as a Senior Research Fellow at Samsung Biomedical Research Institute, South Korea from 2014 to 2015. At the University of Oxford, he is working in the Medical Science Division jointly with the Engineering Science Division. His current research work involves designing new light-activated nanomedicine therapy and Raman imaging technologies for brain cancer of pediatric patients. So I would like to invite now Dr. Nanasaheb Thorat for his talk.
I would request Dr. N.D. Thorat, who has found the time out of his busy schedule and is joining us straight from University of Oxford. Sir, please give your talk on career opportunities, interdisciplinary research and career opportunities.
Thank you very much. It's my great privilege with my alma mater. And before starting to my presentation, I would like to thank the Chancellor of the D.Y. Patil University, Sanjay Patil Sahib, the Vice Chancellor of the D.Y. Patil University, Mudgal Sir, the Registrar of the University, Dr. Bhosle Sir, Dean of the Interdisciplinary Research, Professor Lokande Sir, Head of the Department of Stem Cell and Regenerative Medicine, and my colleague, Dr. Arpita Pandey, Dr. Vishwajit Khote, and other colleague members in D.Y. Patil. It's my great privilege to be with you, and it is always a pleasure to be with my alma mater. And I hope these new students or new young generation would be a great beneficiary from my today's talk. So I'll be just going to be giving some outline or overview about how we can develop our interdisciplinary career from different backgrounds, even we have different backgrounds, and different expertise together. So with this brief, I will start with my just brief introduction. I, Dr. Nanasaheb Thorat, who have MSc in physics from Shivaji University and PhD in physics and interdisciplinary science in D.Y. Patil University under the guidance of Professor S.H. Pawar. So during my D.Y. Patil University span from 2010 to 2014, or till I'm still in cooperation with my institute. So we worked on more or less on the biological and interfacing the material science with the biology. And the research training that I received in my PhD tenure actually a turning point for my life, for my research career. And by step, I have moved from different backgrounds, different institutes. And now I would say I am at the peak of the mountain. So at the University of Oxford in Medical Science Division. So University of Oxford is, now everyone knows, even more than 1 billion people across the globe, they are now looking for the vaccine that will be coming from the University of Oxford next year. I work in the same department, but not affiliated with the vaccine science or something, but we work on the same platform on cancer therapeutics. So here is the University of Oxford, which is one of the oldest university in the English-speaking world, and situated is north of the London, just 1 hour from London. Oxford city, very beautiful city. So this is an aerial view of the university. University is not campus-based, so most of the European universities, they have campuses all across the city. So this is a main campus of the University of Oxford in the city. So city is also within this university. So we can't differentiate where is the university and where is the city. Our department is a little bit outside from the city, and our science and technology unit is outside in somewhere on the hill of this near to Oxford University. But we work closely with the many departments within the city. So Oxford is very famous for their teaching, their research, and their all curriculum activities. So it has a home of around 80 Nobel laureates, home of more than 40 prime ministers, so including Indira Gandhi, Manmohan Singh, who graduated from Oxford University. More than 28 British prime ministers graduated from the Oxford University. More than 3 presidents of America, they graduated from the Oxford University. Every year they are granting more than 500 patents. They have their own technology transfer in it. They have their own spin-off in it and everything. So it is now recognized one of the top, or one of is #1 in the globe and highly ranked there. So actually, this is my privilege to work here, and the milestone actually, or the stepping stone, is D.Y. Patil University. So it is a long journey, but I started it from D.Y. Patil University, and it will be acknowledged every time. So even when my Oxford University profile was created, I insisted the web designer and my university IT team to include my university name in my profile, so they would know, the world would know, so the product from where it came and who designed this product. And they were happy that they deliberately added the name of the Oxford D.Y. Patil University, my guide in the profile. And now hope we are getting many ticks every day on this profile. So I'm happy that D.Y. Patil name is in Oxford now. So with this little introduction, I will start with my presentation. I'll start with where I'm working and what I'm doing. So actually, I'm working even in the Oxford University, but I'm get paid from.
Can I disturb you for 2 minutes?
Yeah, sure.
I'm Dr. Sanjay Patil.
Yeah. Thank you.
I am also hearing
attending.
I was also hearing you on the webinar, and I'm very happy, Dr. Nanasaheb Thorat, you are doing a very good job. And
Yeah.
about DY Patil name also, you must not be knowing that I was listening everything. But I wanted to hear about you also. Once you come to India, we'll meet once again. And I'm very happy that you have made DY Patil University name at USA level also. So my best wishes will be always with you. You please make whatever possible good for the country.
Yeah, thank you very much. And
thank you so much. And whatever help, if you need from DY Patil University, we will be always with you, back of you.
Yeah, of course. It's my alma mater and it is my home. So every time when I visiting India, I always visited DY Patil University. And hope next time we will catch.
Sure. We'll meet next time. And what are the collaboration if you want to do with the research team?
We already continue. Yeah, doing some collaborative work with the faculty members in DY, and definitely very soon we will have common publication and joint project with Oxford University. So, so it is my home university. So I will never forget wherever we will be going. We will be with DY Patil. And thank you very much for attending.
You should guide the new students also how to do it, and you should be in touch with all the students all the time.
Yeah. Yes.
So
thank you.
My best wishes with you always. Thank you so much.
Thank you.
You can continue.
Yeah, please. Okay. So we actually get funded from the European Union. So all salaries, all funding coming from the European Union. European Union is a body of 28 countries who are politically bound together, and they have headquarters in the Brussels, Belgium. And I'm very happy to share another is that I also have a member of scientific committees of many committees actions in European Commission, and every month, every 2 months, I visit the main headquarters in European Commission. So, and the European Commission is world's top funding body for researcher, and they don't discriminate. So everybody has a equal right to get a fund. So like Indian, I am Indian, but I'm getting equal right like a European national to get a fund for research. So what we get for this? So we get almost for every interdisciplinary support. So I'll start with the how career is moving in interdisciplinary science and how I came here. So starting with the interdisciplinary concept, what is interdisciplinary? Interdisciplinary is, let's start with ourselves. Our brain is itself is a reservoir of interdisciplinary concept. So it's not just a science or just studying some subjects. Every day we are thinking many things together. We are thinking about our future. We are thinking about our family. We are thinking about our society. Even we are sitting in the Kolhapur, we are thinking about Joe Biden, who we are just elected in USA. So this is kind of interdisciplinary concept that our brain is thinking. While when we turn it into the science, then we can say it is a kind of research or something. When we give it, when we make it a protocol, then we can say it is a kind of research. So interdisciplinary research, what we need? So we need two different expertises, initially two different fields together, fundamental methodology and knowledge. And with this fundamental knowledge, if we are going to be design a technology, then we can say it is an interdisciplinary concept. So like if you are a biologist and if you are doing some chemistry, but if you are making a technology in somewhere in physics or somewhere in other fields, so we can say it is interdisciplinary. Right now, the interdisciplinary is not just a one-way knowledge transfers. It must be two-way. So what one-way and two-way? So one-way means somebody just presenting in the hall or somewhere, and those are just, and others are just listening. So this is one way. Like our lecturers, they teach us in the class and we just listen. So that is one way. But during 1 week, just knowledge transfer, we can't design the interdisciplinary ideas. We need a two-way transfer, means discussions. We need to take part in the discussions. We have to think ideas, and we have to share the knowledge. So like lecturers, they have a very specific knowledge in their fields, but their students are more clever. So they have knowledge in different subjects. Even they have knowledge of society, they have knowledge of recent technologies. And exchanging such ideas, that is called the two-way transfer of knowledge. And for interdisciplinary sciences, we need it. So when we come to the subjects, how interdisciplinary is working. So like for chemistry, so chemistry is mostly associated with every field, like biology, pharmacy. So most is the pharmacy and biology in drug development and therapeutics. But chemistry is associated with designing new materials. They are associated with the physics as well. And mostly in medicine for many drugs, many technologies and therapeutics. Business and patents is of course there. So while when we think about the physics, so how physics interdisciplinary? So physics is it's just not studying the atoms or molecules or just studying the galaxies or the Big Bang theories or something outside of our Earth. So it is a science of materials. It is a science of our daily life. And with the physics, so even all the technologies, health technologies, technologies in the electronics, technologies in energy sector, their fundamental knowledge comes from the physics. So physics is also interdisciplinary, advancing the material science, even medicine, and other things. So I'll come to my own expertise, how I transferred from my physics background to the medicine. So when I come to the biology, so this is a more focus for today's talk. So biology is actually a very interdisciplinary. And I would suggest all these attendees that you have to be now more curious about the biology. After the coronavirus pandemic attack, everyone is now thinking about the biology, about the scientists in the biology, and they want to discover something for the coronavirus, something for the new diseases. But it's not an easy task. We need a very fundamental knowledge of biology. We need a fundamental knowledge of medicine and health sector. But I would say there is a big future for biologists now and the interdisciplinary scientists. So biology is not just studying the cell or plants or this. So biology comes from everything. Like it's a molecular thing, cancer, virology. It's a neurobiology dealing with our brain. So and it's a drug development. It has a bioinformatics now. So everything is there. Well, what we need as an interdisciplinary researcher. So we need expertise in different fields. So which are these different fields? So they are, let's say, physics, chemistry, biology, medicine. So that is overall we call interdisciplinary in science. But in social sciences, there are many people who have interdisciplinary skills, like they are studied in commerce, but they are doing now something in medicine as well. Even many of my friends, they have studied statistics subject, but they are health specialists. So it is also interdisciplinary. It is just a time of the matter. I will come to the very specific about myself, how I transport from physics background to the completely medicine background. I forget almost all about physics. I even don't recall what Newton's laws, what is the atomic laws, but I know how cancer cells grow in the body, what drugs are effective for cancer cell, how bacteria grow, how viruses are replicating themselves in the body. So this is, it's not just a 1 year, 2 year journey. It is a long journey. So I have just a very normal score in my 10th class. It is just 70%. And with all subjects, even science was my favorite subject, and I have scored highest in science. When I was in 12th science, I have, normal score. It's just 60% in my 12th score. And I have, highest score in biology. and lowest score in mathematics and other subjects. But in my BSc, I completely transferred from, or I more focused on the A group, that is pure physics with mathematics, statistics, electronics, and other subjects. While in MSc, I did a pure science and pure physics. Even PhD is in physics, but more or biology science. But in whole my BSc, I never studied chemistry and biology. But when I started my PhD, I bridged the physics with the biology with the help of chemistry. So, you know, now the science is completely interdisciplinary. So we don't know when we will be coming to be the back. So I left biology in 12th class, but I came back after 10 years in 2010, again with biology, and now completely in medicine field. So it's a time and your interest. So if you have some time interest, like in my 12th class, I have interest in biology, but many of my friends says, oh, we don't have future for biology. Go for the A group and do the studies in maths or physics or chemistry. You will get some job, but not in biology. But it's that time it was correct, but now it's not. Well, when I moved from D.Y. Patil University after completion of PhD, I moved to South Korea in Samsung Biomedical, and I worked in completely medicine school and worked on the cancer and bacterial infections. Then in my second job in the Ireland and Germany, I was again in physics department, but I was doing the cancer and bacterial things in physics department with the help of physicists and chemists. While in my next job in Poland and Switzerland, I went in again in biomedical engineering department, but I was more focused on the medicine things. So I was totally in the animal side, studying the animal experiments, doing animal experiments and everything. And I was fortunate that I worked in a hospital, animal hospital, which was the top 4 hospital in the world where we have treated horses or sheep in the MRI and CT scan. So it was one of the big hospital in the world for animal. So it is complete transformation from physics to medicine. And what we do in the Oxford. So even in Oxford, I work on brain cancer things. And again, I work on in the medicine department. Again, it is a department of women and reproductive health. So it is more on the women's side. But we work on the cancer, which is for young patients. So like pediatric, but associated with the medical and engineering science division. So it is completely interdisciplinary life and the science, that what I am doing. So what I get or gain during this whole span of 7 years after PhD. So we have books, we have papers, we have patent, we have innovations, we have money as well, and everything, and traveling. So traveling is one of the most part for my research, and it's just a COVID issues. Otherwise, I would have traveling every 2 weeks, 3 weeks in each country in Europe. So because I have associated with many European scientific missions, and for that to attend meetings, I have to travel a lot. So I got more money for, even I spent more than 1 crore for just my traveling in last 3 years. And some money left, and we don't have options now to go get it back to the funding agents. So, well, it is a, this is a, my life with this interdisciplinary science, and those who it's made me from just basic science to the technology. Now I will come to the what we are designing and what we are doing. So in interdisciplinary research, it is a risk to learn. You have to be risk. You have to take a risk for some time. You will be get failed. You will be get succeed, but we must be continued for long. And it is for all sciences, not just for interdisciplinary, for all basic sciences also. We have the risk of failure and eventually success. So just in 7 years, what we did. So recently, just in my introduction, they introduced that we have received the Innovation Radar Prize. So I will just a little bit, will give the idea what Innovation Radar. So this is a prize given by the European Union for the most innovator who designed the new technology, not just in the doing research in the laboratory or in the universities, but who transferred this laboratory research into the technology. So we have worked on the hospitals in Switzerland, department in Poland, Ireland. So we have transferred the technology, what we developed in the laboratory, into the market. And that we presented in the European Union, and the juries, they were loved our technology, and we get this award. And it was the big news in the whole Europe, and some Indian media also get attention. But I will tell you the story about that, what we have. So sometime in interdisciplinary career, many people, they don't care, but world is caring now after the pandemic. So the Euronews, which is the official media channel of the European Commission, they just a week ago, they filmed my interview and documentary on us. And this documentary will be coming on broadcast next week in the 15 different languages, including English. They will be broadcasted in 120 countries, including India and this. And they will be given to the 400 million houses, around 40 crore for 1 week, 28 times. So probably I will share it with the organizer, today's organizer, and they will share with you. So this is kind of a success that we achieved. So we are not just making a publications in the research, or just a number of publication and adding publication in our CV. So this is now is over, and people are now want technology. After coronavirus, everybody is thinking about just don't do the research in the lab. We needed the technology in short time. And we are, pioneering such a technology. So we designed the technology on breast cancer thing, and now we are transferring it to the brain cancer. And this is a very unique technology which will give the very precise cancer therapy and diagnosis of cancer. So I would recommend this new generation, the younger students. So once you have good fundamental knowledge, think about the transforming that knowledge to the technology. How we are doing it? So we have our own setup. We have our own team who is making the supporting our basic research to the technology. So we have our team which is transforming technology into the market, or the basic science into the market. So what we are doing in the laboratory, like normal in vitro test, animal studies, biocompletely. With the help of our technology office, we are IP protecting, we are innovating it, we are making industries. We have associated with many industries in Germany and UK for technology transfer. We already have some patents. We have more patents are on the way. And just not a patent. Patent is also kind of now a gloomy research, but invention is more important. So once you have patent, you have protected with your own ideas. Now transformation is most important. So we have our team who is guiding us to transfer such a knowledge to the industry, and we are now setting up our own industry in India and in Europe as well. So just recently we got approval from Ministry of Company Affairs from India to set our own company in Pune, and the next will be the Oxford spin-off. So we'll be combining the company in India and company with our Oxford spin-off. So it will be together. And so at the last, I will be coming with my group. So how many collaborators we have, our team. So our team is from across the globe. So not just from the India or somewhere from the Ireland. So we have Ireland, Poland, Switzerland, UK, United States, Korea, India. And from India, even just from Kolhapur, we have DY Patil group. Together, we have Shivaji University people, and we have people from government officials as well. So with this brief, I would like to thank organizer and all the participants for listening my talk, and I would be grateful to answer your questions. Thank you very much.
Thank you, Dr. Nana. So now the webinar is open open for the discussion. You can talk and you can ask any of your questions to Dr. Nana. Participants, please. Students, don't hesitate to talk to Dr. Nana.
Sir, I have a question. My name is Irfan from University of Hyderabad. That is many congratulations for reaching this position, starting from physics and going inside the hardcore biology. So, have you faced any problem being a physicist and going into the hardcore biology, that too in the research field of biology? So, the student may be asking that whether is it easy job to go into from physics to biology? So did you face any problem, any technical issues, any scientific things that one person from physics and it is entering into the hardcore biology? And if yes, what are those things? If you can share with me, that will be great.
Yes, of course. There are so many problems that we face during even during my PhD, or let's say still now. So we are facing this, but it's not about the problems. I would say the criticism, and science is on the criticism. So we are not just glamorous people who don't like criticism. Scientists always happy to get criticized. So we have many criticism from many background people. So this technology will not help. This will be not pioneering. This will make many issues. So like I'll give you the example of the X-ray invention. So X-ray is invented for the doing job of material scientists. But when Marie Curie first found that, okay, we can go for some bones in the human body, and all medicine people, they criticize, okay, it can't work because X-rays are very harmful, they are very high energetic. But now you will see in every hospital, every doctor, their first job is to, or they are making money with the X-rays. So this is the same with the every physics technology like MRI, CT scan, ultrasound, even our stethoscope. It has a physics. So this is for everyone. When we market, we present new things, we get a criticism. Yeah, these technologies, when we transform from physics to the biology, we need a bridge, and the chemistry is a bridge now. But there are so many others as well. So it's of course, we need criticism and problems from every background. So I don't just say that just as a physicist, I have issues with others. But we have team from, fortunately now here we have team of doctors, medicines, scientists who has a medicine background. Especially we don't have such background in India, where doctors, they generally don't like to do research. They are more focused on the clinics. But here in Europe or America, you will find many research scientists, they have medicine background. So my team also have some EMD doctors, they have higher qualified, and they criticize, and even we criticize them. So it's two-way transfer.
Very nice to see your presentation, and you have established an actual example of interdisciplinary science. Very good, sir. Thank you.
Yeah, thank you.
Hello, sir. I'm Archana Patil. I had just one doubt. I'm thinking about applying for masters in biotechnology. So I have two options. Like I can go for research field or for biotechnology management. So is there any possibility if I take biotechnology management and then I can switch to the research field despite having the degree from management field? Is it a good option?
I would say, see, management, I'm not so expert in the management field. How does the biotechnology or science management, I would say. So the biotechnology has a huge future now after this coronavirus. The interdisciplinary and technological field, which is related to bio, is a big future. Like in 20 years ago, everybody is talking about nano. But now everyone will talk about the bio, and virus or bacteria, or something like cancer. Like the last 100 years, everybody is talking about cancer. And even I am getting funded from last 10 years with just one word of cancer. So it's not about the choosing field, it's about yourself. So what you'd like to do. So I would say just in the master, we can't decide our future. When you go in a deep with a one particular course or one particular field, then you will realize what is the opportunities for yourself, how we can explore ourselves in different fields, like biotechnology management. I would suggest if you go in the disease management or kind of infectious disease management. Now, this will be a new research area. Unfortunately, our country is still lagging in such a research. But Germany, Korea, USA, or UK as a pioneer in disease management, and they are taking help from biotechnologists, medical practitioners, doctors, and basic scientists. So wherever you go, it's all about exploring your knowledge and skills in a way. So you may choose the experimental biotechnology or management biotechnology. Just be consistent with your ideas and your skills.
Thank you so much. One more doubt. How much preferable is it to switch the sites from bachelor's biotechnology to neuroscience masters? Like, what do you think about the job opportunities?
Yeah, so neuroscience is like a very gloomy field. Even I work in the neuro-oncology, and as a physicist, I have to learn a lot. Even I learned from my bachelor students in Oxford, those who are doing pure neurology or neuro-oncology. So it can't be, you will have good future, but you need good fundamental knowledge, and your foundation should be very, very strong.
Okay. Okay, sir. Thank you so much, and thank you for the great presentation.
Yeah, thank you.
Okay, Archana, actually, I would like to add, if permission with all the seniors and speakers. So to your question that you asked, that whether you should go in research or medical biotechnology course. So actually there are few courses like I think in DYP itself we are running two courses. First one is stem cell and regenerative medicine, and another one is medical biotechnology. So these are both the courses are of duration of 2 years, and we have a very limited seats. And this is a I can say that it is one of DYP is one of the very I think only 2-3 universities in India are providing such type of course, and we the students at DYP, they are encouraged to work with the doctors, as Dr. Nana said, that in America and in UK, the researchers and the scientists are encouraged to work. They are working with the doctors. So in the same fashion, we are also working with close association with doctors. We are working in close association. We are allowing the students to see the real problems of the society, and in keeping all those things in mind, we have designed these 2 years courses, and I'm happy to share that we have a great placement of the students from these two courses. So
yeah,
so I will just add one point in this. So recently I read a news article that stem cell therapy will be used to cure the bacterial and infectious diseases. Earlier, stem cell is more on non-communal or these non-infectious diseases. So they are just for cancer or cardiovascular. But now stem cell will be booming for these viral infections as well. So maybe those who are choosing the stem cell, they will have good future if they work very closely with such doctors who are working in the infection side.
Okay, thank you, sir. Thank you, ma'am. I will definitely look for the courses. Thank you.
Okay, so is there anyone, students, you can interact, you can have your questions. Okay, I think we are not having more questions. So thank you, Dr. N.D. Thorat, for sharing your inspiring journey and talking on your work in interdisciplinary areas in physics and biology and achieving big on global platform. Thank you for accepting our invitation and joining our webinar. Thank you. So now I would request Dr. Shivaji Kashte to introduce our next speaker of today's webinar, Dr. Meghnad Joshi.
Hello, again, good afternoon to everybody. So it's a pleasure to introduce a dynamic and a warm senior colleague, Dr. Meghnad Joshi. He has did his PhD from Department of Zoology, Shivaji University, Kolhapur in 2006. Later, he joined Karolinska Institute, Sweden as a postdoctoral fellow in 2007 to 2008 for fetal and adult hepatocyte transplantation study. He worked for Sahlgrenska University Hospital, Department of Transplantation Surgery, Gothenburg, Sweden from 2008 to 2010. In 2009, he was awarded with TTS New Key Opinion Leader, Sweden. He has been appointed as a visiting assistant professor by Kansas Medical Center, USA since 2010 till 2012. He was a part of first tissue engineered tracheal transplant in Sahlgrenska University Hospital, Sweden. He has worked as the lab director in STEM1 Biologics Private Limited from 2011 to 2012. Presently, he is working as Associate Professor, Department of Stem Cells and Regenerative Medicine, D.Y. Patil University. He has 2 ongoing projects in his lab and 6 PhD students working under his guidance. He is CMD of STEM Plus Cryopreservation Limited, a DCGI and FDA approved cord blood bank in Sangli, Maharashtra, India. He is BOS member, Zoology, Shivaji University, Kolhapur. His area of research are stem cell transplant, bone tissue engineering, and 3D bioprinting. He has published more than 35 papers, 4 book chapters, and 5 patents. So it's a great pleasure to introduce Dr. Meghnad Joshi. Sir, now over to you.
So I would request Dr. Meghnad Joshi sir to carry on his lecture on recent advancement in stem cells and regenerative medicine.
Thank you very much, Dr. Shivaji, for introduction. I would like to thank organizing committee for giving me an opportunity to interact with students. So the today's talk is on recent advancement in stem cells and regenerative medicine regard to the work which is being carried out in D.Y. Patil University. So I think I will begin with introduction to the stem cells, because I think it's better that I'll give you some introduction about stem cells, how they function, and then a little bit about our recent work which has been which we are doing in our lab in Kolhapur. I think Professor Mohan has already given you the idea about what courses which we are conducting in D.Y. Patil University. So both courses are very unique, which are related to medical field, because we work closely with hospital. So we have that interaction with clinicians, so that majority of our research as well as academic activity are in collaboration with hospitals. So this is the unique course which we carry. Now people are more and more attracted towards the stem cells. So why stem cell research is important? First thing is it is very important that the developmental biology of us should be easily understood, because these are the building blocks of us. So studying those cells will give us insight of how the development happen and how the cells become specialized during the developmental stages. Most important characteristic that whenever stem cells are there, it is easy for any organ or tissue to get replaced with the healthy ones, because majority of the time cells get damaged during the disease or injury, and these diseased or injured cells must be replaced in order to conduct the normal physiological function. So they are very important. Now, there is also a trend where different new coming drugs or chemicals that can be tested on stem cells, so that just to understand how these drugs or any chemicals interact with stem cells, because these are the basic cells which are going to give rise to different specialized cells. So studying these drugs in a petri dish will of course give addition to the drug interaction. And most important thing is how our genetic machinery works during the different disease condition can be easily tested in the in vitro system using stem cells. So what is the unique characteristic of stem cells? Stem cells, whenever stem cell divide, they renew themselves. That means when the stem cell divide, a specialized cell can form. At the same time, stem cell keep the stemness with this division. That means once the stem cell divide, a single stem cell and specialized cells are formed. Of course, the stem cell should remain undifferentiated in the form. And once the stem cell divide, it gives rise to specialized cells that has been organ specific. So there are three important functions of stem cell that are related to regeneration. First thing is the plasticity, that is potential to change to other cell types according to the organ. That means if the stem cells divide in brain, it will generate nerve cells, or in liver, it will generate hepatocytes. So this wise, it will show plasticity. Homing is something very important for stem cell, because that stem cell have a characteristic where it will be able to travel at the site of injury and start regeneration. And last part is engraftment. That is, once the stem cell is introduced, it will be unite with the tissues. For example, if we transplant stem cell in the liver, it will be integrated as a part of liver. That means it will unite with liver specific cells. Now, whenever we are talking about stem cell, you classify according to the potency. Potency is a characteristic or ability to differentiate is called as potency. Now, at the hierarchy, totipotent cells are at the top, because these cells have a specialized characteristics. That means if you take a single cell, it will be able to generate entire embryo. So this is the characteristic of totipotent cells. Now, during the development, these totipotent cells, they go down to the characteristic, and they can be classified as pluripotent cells. They able to differentiate between three different germ lines. These cells they can be found in embryonic cells. Then during the development, these pluripotent cells and they can be also classified as multipotent cells. That means single cell able to differentiate into single germline cell, that is cord blood stem cells or bone marrow stem cells. And then at the last, it's unipotent stem cell. That is, it is also a tissue specific cell. They're able to differentiate into specific cell line. That means if you have a stem cell, these cells are able to differentiate into liver specific cells. So these are the potency classification of cells. Now, different sources of stem cells. You have embryonic stem cells, you have fetal stem cells, you have adult stem cells, and there are adult stem cells you also could be found in umbilical cord blood, cord tissue, placenta, brain, then bone marrow, adipose tissue, skin, surface of eye, muscles, peripheral blood, and urine. So these are different sources of adult stem cells. This is a typical characteristic of cells where stem cell sources and potency are being classified. If you look at the down triangles, that the blue triangle is for progressive loss of potency. That means potency get lost during the developmental stages, and during the development, cells become specialized. So this is how the cells can be found. I have classified it in three different origin, that is first embryonic stem cells. Their totipotency characteristics can be only found till day 1 to 3, that is once the fertilized egg. Till third day, you will find a single cell of totipotent characteristics. That means a single cell able to form a complete embryo. So during the development, cells lose the totipotency and become pluripotent. So many times fetal stem cells are pluripotent. They can be found from age 5 to 14 days. So these cells are pluripotent cells that even though you take out a single cell, you will be able to differentiate into different lineages. For example, you will be a single cell able to form kidney specific cells or liver specific or brain cells. So these cells have a pluripotent characteristics. A major part of stem cells is been found in adult stem cells, and the age can be classified from 9 months till 100 days, and that on the top it comes with a cord blood, because the age of the cord blood is 9 months, and you don't find any cell adult origin of 9 months age. So it has a unique characteristic. Of course, you have bone marrow, other tissue specific cells, which are very specialized, and that can be found in multipotent or oligopotent or unipotent. So these are found in adult origin. So again, I would like to add some points about how stem cells are valuable. First thing is in the biology of cell therapy, that is a new kind of a treatment that is using stem cells. One could transplant it for treating different diseases such as say Alzheimer, Parkinson's, or orthopedic indications, simple such as osteoarthritis. Of course, it has a major application in research, because one could see in vitro or in vivo system how the stem cells function and what genes are being regulated during the differentiation. Of course, new drugs that is of prime importance, because in a Petri dish, you will be able to identify the mechanism of action of different drugs. In all, what you could say is no one stem cell fits for all application, and there are different stem cells can be used for different application, and research must continue using all types of stem cells. So this is how the stem cell start. It is very important that you need to define stem cell, because whenever you look at any cell under the phase contrast microscope, you will see that all cells look like same. Of course, there are some characteristic of epithelial cells, mesenchymal, but in all, you will not be able to identify in a niche which one is stem cell and which one is a normal cell. So there is a cluster of differentiation, that is CD markers, which are considered to be a gold standard for defining stem cells. And these CD markers are very specific to stem cells, and that can be identified using antibody techniques. So you could use it flow cytometer or immunocytochemistry to see how to characterize your stem cell. So this is hepatocyte culture, and this is mesenchymal culture. So there are majority of the time you could see that the cells look like similar when you see it under phase contrast microscope. Of course, you need to phenotype according to CD markers. So there are different CD markers which are specifically expressed on epithelial cells, mesenchymal cells, or endothelial cells. So if you stain those cells with different antibodies, you will be able to characterize these stem cells, and then you could identify the population of stem cells which you are culturing. This is a typical flow cytometry characterization. Here in this picture, we have characterized mesenchymal stem cell population. And if you could see, these are different markers. For example, CD34 is a hematopoietic marker, which is not present on the mesenchymal, and other markers such as CD166, CD29, 44, CD73 are present on the mesenchymal cell. You could actually see it visualize also, because immunocytochemistry is also a technique by which you could actually see stem cells, and this is a typical characterization of fetal hepatocytes. And if you could see here in a first picture, that is hepatocytes actually synthesize human albumin. Because these hepatocytes are of fetal origin, so they express fetal antigen. So alpha fetoprotein expression also can be seen on these cells. Then other cytokeratin are related to epithelial origin. So all those markers are being expressed on the cell. So these are different techniques by which you could actually visualize the stem cells. Now I would like to take you to the research thing, because we are also doing a lot of tissue engineering research in my lab, and I'd like to show you some of our recent work on kidney tissue engineering, because we have an ongoing project on kidney tissue engineering. So I would like to share some of our work. What we have the aim is to prepare a xenograft. Xenograft is, which is something derived from a non-human origin. And if we want to generate something for human size, we have considered that a goat kidney will be ideal, because it has a similar size of kidney. So what we do is, firstly we remove the cellular content of this kidney, so that there will be an inert scaffold without destructing ECM, that is extracellular matrix, which is present on the kidney. So what we have done is a protocol by which we remove the cellular content of that kidney. And this is how the kidney look. This is a control kidney after 12 hours, 24 hours. And after 52 hours, this kidney is without any cells, which is confirmed by DNA content of the kidney, as well as scanning electron microscope. We also see that the vasculature of the kidney is being maintained. That means whenever you are removing the cells, you are removing only cells, not the internal structure. So this is the typical renal angiogram to show that the entire vasculature is maintained after the decellularization process. So what is our aim in an initial stage is to check whether this piece of kidney can be functional if you transplant it on the kidney capsule. So what we have done is we have placed a piece of kidney scaffold onto rat, and we have kept it for 1 month, so to understand how this scaffold reacts. So what we have observed that after the 30th day, you could actually see angiogenic factors which are on the scaffold. That means this piece of xeno piece is been vascularized peculiarly, and it is been accepted by the rat kidney. So this is how we do a xenotransplant. This is a typical MRI study to understand whether this, even though your surgical procedure, after doing the surgical procedure, the kidney functions properly. So this is just to identify that the kidney properly placed without any defects. Of course, histological evaluation is very important in order to understand what are the different cellular reactions that are being carried, that are been happening in the scaffold, because if there is a immunological rejection, you could actually visualize after histological analysis. So this is a control kidney for different stain. That is, first is eosin hepatoxylin, Mason's trichome, AB staining, and trypan blue. So just to understand the ECM. If you could see that there are no cellular content in the scaffold after decellularization. So this is a cell-free scaffold, but the inner architecture is well preserved. You could see it by different staining methods. So after 30 days of scaffold implantation, we have checked for again these markers, and we have seen that there are glomeruli, cellular infiltration in the glomeruli. So the cells started to engraft at the site of scaffold. Of course, we could see the glomeruli, but the cellularity seems, it's not compared to normal. So, but there are cells which you could see the distal and proximal tubules in the scaffold. So these are the different confirmatory stainings, just to understand how the cells penetrated to the scaffold. So these are all rat cells in the goat kidney. Of course, now we have also checked kidney-specific markers, expression of kidney-specific proteins in the scaffolds, and we have found that there are kidney-specific proteins which are being expressed on this scaffold, just to understand that these are well preserved and without any immunological complications. Of course, we have done scanning electron microscopy to study the ultrastructure of kidney. We have observed kidney-specific cell, a nice endothelium in the glomeruli. There are different glomeruli cells which are being start to restructure. For example, if you could see here, it is the entire glomeruli which has been synthesized, a nice endothelium. So this is considered to be in a sign that there is a complete formation of glomeruli in the genoscaffold. Now, of course, we are still doing some experiments in order to make it more refined, because what we have found that, of course, this scaffold is ideal for xenotransplant, but we need to understand now, or we are now conducting experiments where entire kidney can be engineered in a bigger animal, something like rabbit, where we will be able to engineer a human-sized kidney for transplant. So this is the first approach for the generation of tissue engineered kidney. Our lab is also working on 3D bioprinting. 3D bioprinting is a newer technology which has been utilized in the technological part, where you could actually make a digital signal to transplant into a 3D structure. So what you print is a 3-dimensional digital model which has been printed by slice. So you could get a 3D model. So a little bit about 3D printing. It's easy to use. It is economical to have it in your lab. It can be operated in office, labs, homes. It is a very important tool for students, because students get to know the 3D structure of any kind of organs, for instance, medical field. Of course, it has an affordable price. What it does is it takes a digital input in the form of 3D data and creates a solid 3D parts in slice. Of course, it has been used by designers, engineers, biologists, hobbyists, just to develop a concept which has been easily understood. So it's a FDM technology which we actually start to use it in a biological printer, which has a filament which is drive through the wheels, and which has been liquefied at the heating block, and this material is been printed on the surface slice by slice. So this is how FDM technology has been functions. We are also using the same technology, and we are working on developing different biological inks for different print. For instance, recently we have patented a 3D printing technology for skin, where we actually print the entire patch of skin using 3D printers. So whenever we are talking about medical, 3D printing technology has developed a huge interest, because the prototypes that can be easily printed by 3D printer can be a great benefit to students, because they will be able to visualize the structural compartments of different organs. Of course, it has also a medical procedures, and it is being practiced in the clinic. For instance, February 2012, surgeons successfully implanted the entire titanium jaw with 3D printing in an elderly woman. So this is the first kind of transplant. So it has also been used for different cosmetic. I think please unmute everyone because I'm getting a lot of disturbance. Please mute everyone. So this is how 3D printing technology has been utilized in a medical field. I'm going to show you a short video clip where this patient had a surgical removal of surgical implantation of an entire jaw, and this has been constructed by 3D printing, and you could see that this has been exactly printed as per patient needs. So you have a match of color, you have a match of skin. So this is how the technology is moving fast, and we are also a part of that because we are also developing this similar kind of a technologies in our lab, where but only thing is we are considering something on bone, skin, cartilage. So this is how we are doing 3D printing, developing 3D printing technologies in our lab. So this is a model just to show that how the 3D printing could revolutionize the entire medical field for a patient like this, and could be very useful tool in the future for all clinicians. So this is how we do 3D printing. We have a customized printer where we are using exclusively this printer for biological printing. So I'm going to present our recent work on bone printing. Of course, bone has the rigid structure of body, which protects the vital organs. And bone injury, trauma, or fracture results in long-term deformity, and there are a lot of shortcomings or limitations for orthopedic surgeons when it comes to severe fractures or ununion or bone fracture. So that there are orthopedic limitations such as non-union bone, where complete breakage of bone results in deformity, which is a really difficult task for any clinicians because the bone healing has a limitations. And what we have done is we have developed a technology by which we actually have a liquid bone which can be printed using 3D printer, and you could actually print a bone of your interest using MRI or CT images. This is a typical printing of bone. We are right now printing a cage where the printer is printing using a liquid bone, which is after printing, it actually solidify and become an entirely solid structure like bone. So this is how we are working with bone structure. We have a preliminary data where once we print the bone, actually it has a very porous structure which is been preserved, and you could see that this bone is very porous. Initial experiments on biocompatibility shows that this what we have done is we have check biocompatibility. We have kept the printed bone at cam area and check whether this has any toxic effect on the cheek. This is a sensitive model. Of course, this model has limitations, but this is very easy for us to check the biocompatibility in cheek. What we have seen that this 3D printed bone has a huge biocompatibility. That means this structure has been on the cam area without any toxic sign. So at the same time, when we have checked this bone for scanning electron microscopy, we have seen that this bone attracts the cheek cells, That means these cells start to form colonies in that bone. That means it again gives the idea that this porous bone structure able to attract the cells. For instance, you could see different cells, proliferating cells. You could also see RBCs which are being present on the bone. So this all gives us idea that developing this kind of a technology for bone to cure the bone has a huge potential. I think we have also a future goal considering the different technologies which we are developing. First thing is the more refined printer where we could actually print different structures at the same time. So for example, if you want to print a more complex organ, it should print vasculature at the same time other structure. So this is present limitations with using 3D printer. First thing is we need to check whether the printed material is strong enough to withstand the carry out the mechanical properties of bone. So this is something which we are right now working. Of course, the lifespan of the 3D printed organ, that should be another challenge for us, because we don't know in a longer term how those printed organs function with time. Of course, this technology should be economically more cheaper, so that it can be easily used for all clinicians in the hospital. So this is how we are aiming. I think this is my talk. Thank you very much.
Thank you, Dr. Joshi, sir, for talking on stem cell research and career opportunities. Now I would like to request students and participants to come with your questions, and you can interact with Dr. Joshi. So if there are no questions.
Hello, sir. Hello, sir. I'm Rutuja Gambhir. I want to ask you that hello.
Yes.
Am I audible, sir?
Yes, I am.
Sir, you showed that video, right? The transplant, the scaffold video. In that, is that eye was completely functioning?
No, it is aesthetic.
Okay.
So that comes from a curious student. So student, you can ask your queries and you can interact with Dr. Joshi, sir. Students and faculty. Okay, if you have any doubt, you can come to our department. You can visit our department and you can meet Dr. Joshi, sir, and you can discuss your doubts. Now I would like to request Dr. Ashwini Jadhav, ma'am, to deliver the vote of thanks of this webinar.
Thank you, Dr. Arpita. Good evening, all. This is Dr. Ashwini, Assistant Professor, Department of Stem Cell and Regenerative Medicine. It is my pleasant duty to present vote of thanks. First of all, I would like to thank Honorable Chancellor Dr. Sanjay D. Patil, D.Y. Patil Education Society, deemed to be University, Kolhapur. I thank Honorable Vice Chancellor Dr. R.K. Mudgal sir for his support. I thank Honorable Pro Vice Chancellor Dr. Shimpa Sharma ma'am, Dean of D.Y. Patil Medical College Dr. R.K. Sharma sir for his always being with us. I am very grateful to respected Professor C.D. Lokhande sir for giving continuous support and guidance to us. My big thanks to respected Dr. V.V. Bhosle sir, Registrar, D.Y. Patil Education Society for his continuous support. My sincere thanks to Professor Dr. S. Mohan Karupai sir, HOD, Department of Stem Cell and Regenerative Medicine, for giving minute-to-minute guidance. I thank Dr. N.D. Thorat sir, our invited speaker, Marie Curie Fellow, University of Oxford, for accepting our invitation and joining with us in this during webinar and giving a very wonderful talk on interdisciplinary research. I express my gratitude towards Dr. Meghnad Joshi sir, Associate Professor, Department of Stem Cell and Regenerative Medicine, for accepting our invitation and giving a very informative talk on stem cell and regenerative medicine and tissue engineering. I would like to thank Dr. Arpita Pandey-Tiwari, Assistant Professor, Department of Stem Cell and Regenerative Medicine, for putting her great efforts for this webinar. I thank our faculties, Dr. Arvind Gulbake sir, Dr. Shivaji Kaste sir, and other faculty members for their support. I'm thankful to technical staff, Mr. Suresh sir, and corporate office also for this help. And I thank our PhD students for joining with us and helping during this webinar. And now I thank all the participants of this webinar. Wish you all the best for your bright future. I'm very thankful to you all. Now I conclude that a webinar is over now. So thank you so much.